Precision 3D Hydro 2021 benefits tremendously from intelligent TINS. This is the first training video of 10 for the release of P3D Hydro 2021, focusing on how to make intelligent TINS. TINS where the triangles have not only XYZ coordinates, but color, which can then be associated with runoff coefficients, making those TINS intelligent. Now, the Roadnet Merge TIN is found under Roads, Roadnet. We've got a project made here. The existing TIN surface is Civil Demo Base. The output merged surface will be Civil Hydro TIN. Click just above there, go to the Set Colors layers, and you can see how we've mapped EP to red, EP in the template, and CB in the template definition is mapped to color 252, which over in P3D will be associated with the concrete texture in the same way that asphalt will be associated with the red color. Now, we're going to process this. We just made the new file. Let's look at it in P3D 2021. There you can see it. Let's get up close. You can see your asphaltic surface. Look to the upper right, 0.9 runoff coefficient, 0.95 on the concrete curb. The grass over here is 0.25. This section is 0.3. So you can see how all these colors in the tin got mapped to textures associated with runoff coefficients, and that mapping occurs up here under Tools, Surface. Let's look at the red just for one example. And you can see here's your color 252 for the concrete. The red is asphalt. Edit it, and you can see where the 0.9 comes from. That's the 0.9. The C in Q equals CIA. We'll go quickly back to the civil, and let's go to the option 2. We'll exit here and look at the watershed method of making the TINS even more intelligent. We'll go to Define Watershed Layers, and any perimeter closed drawn in layers that are user-defined can be associated with color. They can be hatched within that command. I'll clear the hatch. Or we can just color the tin. So we'll color that same tin. We're done. We hit OK. We go back here. We delete the one we have. And now we're going to bring in an even more intelligent Civil Hydro tin. And we have building roofs. Look to the upper right, 0.85 runoff coefficient. The treed area is only 0.18 because of the way it absorbs the rainfall in a storm. Now let's go back and look at the third method. To illustrate the third method in TIN file utilities, we'll start by using a command called join nearest, and we'll tolerate up to 25 feet of separation and just join any polylines we pick. That's now a closed perimeter. Going back to the civil module under Surface, TIN file utilities will load the progressively smarter Civil Hydro TIN. We'll go next, hit bounding polylines here. We'll pick on this, and there's no exclusion perimeter, and then we'll save as. Well, before we do, let's color. Let's set the color to red and save as. We've added that intelligence to it. Now we're going to work our way out, go back to P3D, delete that one, and watch how that main road extends through the effect of TIN file utilities. Now what we're going to do is you can show all the low points on this surface. You can see there's a low point at the end of the cul-de-sac. There's a couple over here, a couple in that road there. What we're going to quickly do is using this particular structure, we're just going to make a 2-point storm sewer, finish the command. Now, when we run the rainfall event or analyze the storm sewer, you can do it either way, you'll see it finds watersheds, shows water where there are no inlets, drains the water where you do have inlets. Look how that watershed goes right down the crown of the road. But over here, pay close attention to how in this first watershed, feeding that first inlet, you have a 0.392 composite runoff coefficient from the combination of all of the surface textures produced in the intelligent tin. That's a lot of powerful result, including the peak flow, 1.653 CFS, computed in seconds.